Welcome to how to graph composite and inverse functions with the fx-CG100. In this video, we will demonstrate how to graph composite functions directly and indirectly using graph notation, then analyze these functions to verify domain and range. For inverse functions, we will learn how to change the style of graphed functions, display the reflected inverse, and restrict the domain of a graphed function. To start, we shall graph these two functions. Press Home and select Graph&Table by scrolling or using the shortcut. Enter the first f of x function as y1 for reference. Then using the secondary function of e, pressing Shift first, enter the g of x function as y2. Right tab to open the View window pop-up, and select Draw. The domain and range of each function can now clearly be seen, which will influence later working. The composite function f of g of x can now be entered directly. Press back to return to the Function tab. Then enter the composite function, again using the secondary natural log function. Right tab as before, and draw. The composite is drawn with clear limitations on its domain and range. An alternative approach to directly entering the composite function is to use graph notation. Return to Function. Then scroll in order to edit y3. And delete the natural log. To replace g of x, press Variable and select Function. This displays all the stored functions. Select y2 to display the graph notation in y3. This is a useful method as it reduces the likelihood of error when entering more complex functions. Right tab and draw as before to show the same composite graph. It is also possible to enter the composite functions as functions of each other. Return to Function and press Variable. Then select Function as before. Now select y1 for the f of function and open parentheses. Then enter the g of function with variable. Press Function and y2. Confirm to store the function as y1 of y2. Then right tab and draw to sketch the composite. This method could also be used to check the accuracy of a directly entered composite, as coincident graphs would be sketched. To help determine domain and range of composite functions, graphical analysis can now be performed. Press Tools to open the pop-up and select Graph Solve. To investigate the range of the composite function, select Minimum Value. As more than one function has been drawn, scroll down until the composite is flashing. Then confirm. The minimum is indicated, suggesting that the range is greater than or equal to 1. Show the coordinates and pin the point by pressing OK. And end the analysis with back. To determine the domain, trace analysis could be used. Please see our other videos to learn more about graphical analysis. To investigate inverse functions, it could be useful to sketch a line of reflection. So we will now look at how to change the style of a graph. Return to the Function tab and delete the existing composite functions y4 and y3, leaving the y1 quadratic. Then highlight y2 so that it can be overwritten. Then enter y equals x. To change the style, highlight and press Tools. Then select Line Style and Broken. Press back and notice the Style box now shows a broken line. Right tab and Draw to show the broken line of reflection. As the quadratic is a many to one function, find the minimum value of y1 as before. The handset can easily sketch inverses of functions as the reflection in y equals x. From the graph, press Tools. Then either scroll or use the shortcut to select Sketch. Now select Inverse. The y1 quadratic starts flashing. Scroll to select other functions or Confirm to sketch the green inverse of y1. Note that the inverse is a one-to-many mapping and so is not a function. As only one-to-one mappings have inverses, it is necessary to restrict the domain of the quadratic. Return to the Function tab and scroll to edit y1. To restrict the domain, end the function with a comma. Then, press Shift first to open square brackets as the secondary function of 4. Enter a suitable domain, starting with the minimum point found earlier. Then draw. This is now a one-to-one mapping. The inverse function of the restricted mapping can now be entered directly after determining it algebraically. Return to Function and enter the square root inverse. Notice that the restricted domain of x greater than or equal to 1 is not necessary, as it is applied automatically. Right tab and Draw to sketch the inverse. Although the inverse function looks to be correct, we can check graphically. Press Tools and select Sketch as before. Then select the inverse. As y1 is restricted, the line of reflection flashes first. Scroll to the directly entered inverse function and confirm. The reflection in y equals x is sketched and lies coincident with the original quadratic function, indicating that the algebraic inverse is correct. We hope that you have found this video useful. If so, please do check out our other resources on the Casio Education UK website and YouTube.